All right, I think we'll go ahead and get started. We only got 20 minutes, so we'll make the most of it. I'm Josh Grebin. I'm a software engineer at Stanford University. I'm here with my colleague, Shelley Doljak. She's online, and she's also a software engineer at Stanford. And we're both part of the library systems team. And we migrated to FOLIO 2 years ago, right about this time of year, 2 years ago. And since then, we've been trying to support it. And part of the problem with supporting it with FOLIO is how do you know when there is a problem reported? How do you know what the problem is? When we first migrated, there were the FOLIO logs and a lot of culling the logs to try to infer what's going on. And since then, we've implemented different tools that help us get better insight into what's going on with FOLIO and the systems surrounding FOLIO. So we're going to talk a little bit more about those tools that we use and save some questions to the end. How about that? So one tool that we use is, we deploy our Kubernetes, use our FOLIO system using Kubernetes. And, sort of out of the box Kubernetes, you have to do a lot of kube control typing. So we were able to purchase a license to Kubernetes, a Lens IDE for Kubernetes. And we use that to manage our Helm deployments. It's good for, viewing the workloads, configs, storage, all the aspects of Kubernetes. You can also use it to easily exec into a pod shell to check the internal, environment variables, those type of things. And it also has a graphical chart interface, I guess, a chart for seeing what the resource, the pods and the containers are using. And that comes in handy a lot too. Although we've kind of found it more on this a little later in the presentation, we've kind of found that a little bit untimely or unreliable sometimes. So we have other tools that help us sort of with that. So a little bit more just sort of, if you've never seen Lens before, this is kind of what it looks like when you connect it up to your cluster. It gives you this nice overview of what pods are running, deployments and everything, stateful sets, the different objects in Kubernetes. And then there on the the left side, we have icons for different clusters. Our production is the blue one. The orange one is our test cluster. So we can switch back and forth. And then up here at the top, you connect to the different namespace. So we have different clusters for test and production. And in those, we have different namespaces for prod, dev, test, prod, and stage. So we have 4 that we kind of run and look at using this. And then also on the left-hand menu there, you can see that, the different workloads. You can look at the pods, the deployments, all those things. And then further down, the networks of the ingresses and the services are under there. Let's see, and then this is sort of a detailed view of the pods that are running on the day that we took this snapshot here. And I got it there sorted by the number of restarts. So that's one way we kind of get insight into what's going on. Like how many times mod entities links restarted 11 times. So what's going on with that? We see something like that during the day in production. We know sort of to be proactive, go check out, look into it further, see what might be going on with that. And also on the right-hand side, you can see status, everything's running and how long it's been running, CPU memory usage, and whether the container looks healthy or not. And then so if you kind of drill down into the particular pod, you can see there's a graph I was talking about for the memory usage. You can toggle between CPU usage, memory usage, and some other things, files and network calls. The container status, like this one was terminated, and the reason why usually just gives you a code, and you have to learn what that code is, out of memory error or something like that. Make sure you're running the right version of it. What port it's running on. You can expand the environmental variables and make sure those are all correct. And then what probes are running and how often they run. So back to the resourcing. So we noticed that in Lens, the resource, that graph and chart, it gets updated more frequently, but it's not always correct for some reason. Sometimes you have to exit and refresh, go back into it and get it to refresh. Not good. So we also got this other observability tool installed called Coroot. And I don't know if you can't really see at the top, but it says Coroot up there, but this thing is in the way. it is a Helm chart that we deployed in the cluster, and it gives you all sorts of cluster data. It tells you the traffic between modules, describes the latency and different networking aspects. It kind of drills into different log patterns, and it gives much better, although not as timely, resourcing statistics and graphs. So we'll kind of show what this looks like. This one is, sorry, I have to move Shelly here to the other side. Application health overview. So this kind of tells us, which are the top number of pods that are running that have some sort of problem according to the metrics that are established in Coroot as it's sort of the default, or what we've made the default. If the latency is too high, or if the number of upstream dependencies fall below a certain threshold kind of thing. And I don't know which system this was or on what day, but this looks pretty bad. So you can see like a lot of pods are red. They have a lot of latency. A lot of their upstream dependencies are not running, or at least fully running. And then there's errors in the logs. And you can see on the right-hand side how many unique errors are in the logs. So this sort of gives you application overview. So if we hear something like mod data import's not working, we go on here and look and kind of drill in and see what's going on at the top level here, like, oh, maybe it's something with the upstreams, or CPU or memory is not good. And then you can drill down into it and kind of see what the problem is. This is just another view for application health, the number of errors in the logs. This is, you can sort of see what the connections are between the different modules. So here's sort of a graphical view of like the Okapi wheel and spoke model kind of happening. It's all, Okapi's in the center and it connects to all these things. And then if you can expand and look at all 59 apps, and it's a long page to scroll down of what you're looking at. And then sort of the external things that Okapi connects to that are not connected directly to the modules. You recognize the edge ones and mods Ethernet 50, and then we have another one that we run called the Sete app, which is not part of Folio proper. And if we could demo this live, we would see like if you hover over these green lines, it kind of gives you the traffic, the amount of traffic on those different lines, which is kind of neat. So then if you kind of drill down into latency and errors, you can see this is the latency for, I think, Okapi up here. And this threshold line is sort of what we define in Coroot as our threshold. So as long as like 99%, what does this thing say here? Oops, let me go back. Sorry, I gotta move this thing if I can. Control, Alt, oh my gosh, Shift. I don't know if I have enough fingers for that. H? Yeah. Okay, thank you. Okapi service level objective, 99% of the requests should be completed in less than a half a second. So mostly it does that, but a lot of times it doesn't. So, and then if it's really bad, it'll appear higher on that list, and we know something's wrong with Okapi. Let's look and see what's happening, sort of as a starting place, and then, okay, well, why is that happening? Sometimes it's just slow, but other times there's an underlying reason for it. Another view in Coroot is the application instances. So, we run 5 replicas of Okapi, and, this will turn yellow or red if some of those go down. Just like you see logs is yellow because there's some errors in the logs. It's not totally happy, so it's yellow, not green. For CPU usage, so this sort of represents a better view of the container, in this case for Okapi, of the CPU usage, which is pretty low for what we have it set. So the black line here is the limit, and for each of these instances, they're all very similar down here at the bottom, not anywhere close to using the CPU. And then here down where it says node CPU usage, that's for the whole node, not just the CPU, the Okapi container in this case. Similarly for memory usage, and again, this is for Okapi, and it looks like, for what we have resourced for it, it's running good on this day. This tool has really helped us, like when we were first developing and getting Folio up and running, and we didn't know exactly what the pods needed or what the modules needed. So we'd run it and there'd be problems, and then we'd look here, after 20 minutes or so when there was data, and then we could tell, oh yeah, it's totally running out of memory, it's totally running out of CPU, and then gives us an idea of how much to increase it, not just give it everything in the world. And then also for, how do you set the JVM heap size if you have to do something different from the defaults? So this, gives you an idea of what the garbage collection is and how long the garbage collection takes and how much heap it's using. And then I think, Shelly, you were going to take over at this point, so let me turn it over to Shelly.
Yep, this is my part. You can hear me?
We can hear you.
Awesome. Okay, so Coroot also gathers statistics about your deployment. These are based on service level objectives, number of errors in the logs, container restarts, CPU consumption, and memory leaks. I see it as how performant is your application when deployed for weeks. Here are the deployment statistics for Okapi. We see the statistics for a 23-hour deployment versus a 24-week deployment. And we could look here and decide if restarting a module might help meet some of the performance goals. Next slide, please. So for example, here are the deployment statistics for mod source record storage during a weekend when we had data import jobs that were stuck. As you can see, the 1 week old deployment was consuming a lot of memory versus the 20-hour old one and the 2-hour old one. CPU usage seemed to improve after rolling out a deployment restart, but latency is still a heartbreak. Next slide, please. Coroot provides a search interface for logs. Here's a screenshot of the Okapi logs for a 12-hour period during a workday. When clicking the log patterns button, you see, next slide. Coroot shows the frequency of certain warn and error level logging for the time period selected. You can select on one of the patterns to get a graph of how many times it occurred and by which pod deployment in the cluster. This particular pattern is from the inventory app. I'm talking about the graph in the bottom right. It's from the inventory app and FOLIO UI making a call to an endpoint in mod remote storage, a module that we don't deploy. Next slide, please. Here are log patterns for mod orders for a 3-day period. We see a low percentage of warn and error log messages. Next slide. Clicking on one of the error log levels, we see the detail of the log message. I'm not sure if you all could see it. It says, user is not a member of the specified acquisitions group. So when clicking on the show messages blue button, next slide, we see how many times a user has an operation restricted because they're not part of the specified acquisitions unit. And if we wanted to, we could add more search terms to filter the results further, which is pretty neat. Next slide, please. So Coroot is helpful in searching logs for particular keywords like timed out. We've been getting timeouts from mod SRS since we've upgraded to Kesnelia and Postgres 16 and haven't really been able to figure out why. But here we can search by a data import's snapshot ID in this log and determine if a timeout caused the MARC record to not get created or if the instance and MARC are simply disconnected from each other. Next slide. So another tool we use is called pgBadger. It is a log analyzer for PostgreSQL. Next slide. I've used this tool to find the most time-consuming queries and try to determine if the indexes we have, the ones that are delivered with FOLIO, are working or if we have missing ones. For instance, I saw a query for the ISBN field in an item record show up here once. Next slide. And I thought, wait a minute, there's no ISBN field in the item record. And indeed, mod inventory storage was doing a costly parallel sequence scan on the item table in our database. Next slide. After some investigation and filing a JIRA ticket, I created an index for the field so that the query doesn't consume unnecessary resources in our database. So now it no longer shows up. Next slide, please. Some queries we just don't have much control over. However, for this particular one, this is the delete mark indexer's job from mod SRS. For this particular one, at least we can deploy mod source record storage so that it only runs the delete mark indexer's job every 24 hours. And here we can confirm that it actually is running and it's doing it during non-business hours, which is great. Next slide, please. Another thing pgBadger reports are queries generating the most temporary files in the database. This is helpful in figuring out the temp file limit to set. Next slide. And pgBadger can show how many connections per second are established. On a typical day, it seems FOLIO uses 298 connections at any one time. This can be helpful for database administrators in determining the max connection settings for the database and for DevOps in determining the appropriate database connections for module deployment. And that's it. Thank you all. And we saved time for questions. We got like 5 minutes.
All right. Any questions online or in the room? Let me get you the mic.
Hi. So what was the driving factor for you guys for deciding to self-host your Folio instance yourself?
Well, one factor was we have a lot of integrations that we make with our on-campus vendors and things like that. So we wanted to kind of have control over the system. And I don't know, Shelley, do you have another answer for that?
I think it's just because we are a self-hosting shop. We kind of did that with our previous ILS. And in hindsight, I think it was a great opportunity for us on library systems to learn a lot and learn new technology. So it was a great opportunity for us and then also for our operations team and getting into Kubernetes.
Yeah, it was really interesting seeing all the stuff you're doing. We self-host our Viewfind instance, and I'm seeing all of these things. Like I'm constantly wishing we had access to our Folio instance logs, and we don't. Keep thinking, maybe it would be interesting if we actually did have that access. It's very interesting seeing all this. Thank you.
Let's see if there are online questions. Any?
No, there's.
Are you keeping an eye on the chat? Okay.
Yeah, no chat questions yet. We were so thorough in our explanation.
Do you have any regrets or lessons learned, like having already set it up? Do you wish you could go back and redo? Change if you could like start over again.
You mean with like the whole Folio installation?
Yeah.
I mean,
you're like Kubernetes set up. Like, do you think you would change anything if they had you to do it again?
Actually, yeah. Since you asked a very good question, there was one thing, and let me go back to not there. I don't know how to use like the trackpad and oh here, I'll just use the arrows. So back to this is a good way to illustrate it. The number of nodes that we have in you can see like the column there where it says node and it's got like, worker 5, worker 1. Well, how many workers did we have in there that we were using? 6?
It's a total of 6 in production.
Yeah. So that wasn't enough for our Kubernetes deployment. We really needed it was better to have a lot of smaller ones, not a small number of big ones. And that's what we did, not really knowing how this was all going to work. So now we're sort of in a way stuck until we have a chance to sort of rework the back end there. which we're going to do soon, I think. But we kind of, it hasn't been too much of a problem, but it has caused some problems, with performance and with flexibility. So we would have done that. And we didn't have all these tools set up right away, sort of as we went along. If we had all these tools set up like on day one, things probably would have gone a lot smoother, having, more insight into what was going on. So
Thank you.
mhm.
So we got a question online. Any reason you decided to go with Kubernetes Lens rather than using Rancher? Did you find Rancher was missing something? I mean the Rancher UI interface. And so to answer that, we actually, the Kubernetes that we deployed we didn't do it in library systems. It's our operations team who did it, and it's canonical charmed. And we just use Kubernetes, we just use Lens app as the kind of UI so that we don't have to type kube control all the time, right? And I don't really have a question or an answer about the Rancher component to that question.
So I have two questions, if I may. One is, do you anticipate having to make significant changes as you transition from an Akapi-based system to Eureka-based system? And secondly, I'm a product owner for various modules. If there was something that is there anything that you would say, like, to a product owner, oh, it would be great if you were to think about this when you were specifying the software for your modules that would help us with this kind of work, monitoring and diagnosing issues?
Okay, those are two very different questions. Let me answer the one.
Feel free to pick the one you prefer to answer.
I'll answer the Eureka one. As far as like changes to any of these toolings, do you mean, or just in general?
To these toolings, I guess I was.
Yeah, so actually, no, I mean, we've been experimenting in our dev instance on here with going to Eureka, and the tooling works just fine. Like, there's no problem. And it's been very helpful, actually, for, trying out the new architecture as compared to when we first went up with Folio originally. Like, having those tools already in place has already been a big help, because as soon as, we installed the Keycloak and Kong, they showed up in Coroot, and I could see exactly what resources it needed. Yeah, for example, Kong is very resource intensive. And then when you start doing things like entitlements, then it needed more memory, and it's like, I didn't know what the threshold is set. So it's like, run the entitlements and then Kong crashes. It's like, okay, go look at Coroot. Oh, this is how high it got. And so bump it up, try it again, and just sort of iterate on that until, like, okay, yeah, it needs like 12 gigs normally to run. So far, until, we install even more applications, maybe it needs even more, I don't know. But yeah, that, for example, and just knowing, Keycloak really doesn't require that as much resourcing as all that. So yeah, that's been really helpful.
I would add that I do think we need to change. We need to configure something so that the sidecar containers are exposing some of their traffic in Coroot, so that we could see some of that in the display that we had, the Okapi, and it was kind of like that hub and spoke model, and it showed which modules Okapi is talking to. So it looks different in Eureka, because now you no longer have everything talking to each other through Okapi. The modules are talking to each other through their sidecars. And it doesn't look quite like I would have expected it to look. So I think there's some configuration thing we'll have to figure out there.
Yeah, I mean, it's not quite the same thing, but certainly during bug fests, when I've been trying to track down bugs that are occurring in the Eureka bug fest environment, having to go through an additional set of logs is another overhead in that scenario, because you're looking for traces in the sidecar logs as well as the module logs as to where traffic might be getting through, or proxies something might not be proxied correctly, especially when you then have the Akapi proxy module as well as a potential usage of the Akapi calls on top of whatever is
Right.
happening in Eureka. So
One thing I noticed also with the log, when you look at the logs in Lens, which is nice, is that when there's more than one container, so if there's a sidecar in the module and you open the log, it gives you can look at one, you can look at the other, you can look at all of them at the same time, and you can also, it has a little label button and it'll label them, kind of like with Docker Compose, how it will label which one it's logging. It'll do that all in one unified view. So you can actually see them all together that way, which is, a lot helpful. So you don't have to keep switching back and forth. Any other questions? We're a little over time, but no one's come in to kick us out just yet. So. Too bad I couldn't use my own laptop to project, because then I could have done a demo and showed all this stuff. But Lens is only installed as a client on my computer, and Coroot is behind several layers of firewalls and stuff. And I don't have the VPN client on this computer, so that's why all the screenshots. All right. Well, yeah, thank you all for coming.